Hi there, Mr. Sutton here, bringing you the Algebra 2 Honors 2-2 Part 1 homework solutions on characteristics of quadratic functions. In this one, we're specializing in vertex form and intercept form. To graph the g function here, I'm going to treat this as being intercept form. I'm going to think of this as like having an x minus 0 parentheses squared. That would give me a vertex of 0, comma, this will be a -1 right here. So that's my vertex taken right out of vertex form. And then I'll put that on a graph. So 0, comma, -1 right down there. Now to get another point, I can just plug in an x value that's pretty close to 0, like 1. If I put 1 in here, that'll be -1 squared minus 1. So that's just -1 minus 1, or -2. So that gives me the point 1, comma, -2. So that's going to be, let's see, over 1 down 2 right there. And now I'm going to use the symmetry of the parabola. There's an axis of symmetry going through my vertex here. I'm just going to reflect this second point over that line of symmetry to get a third point. Now that I've got 3 points, I can just draw the parabola through those 3 points. To graph this function, since it's in intercept form, or not intercept form, it's in vertex form, I'm just going to get the vertex right out of this. This -7 inside gives me a +7 for the x value. The -1 outside is a -1 for the y value. So 7, comma, -1 for this one. Let me put that on a graph. So we're going over 7, down 1 right there. And to get another point, I'll just plug in an x value close to 7, like 8. Let me put 8 in there. So that's 8 minus 7 squared minus 1. That's just 1 minus 1 essentially, which is just 0. So we have 8, comma, 0 as another point. So 8, comma, 0 right there. And then I'll just reflect that over the vertex to get 6, comma, 0, which is our third point. We can now graph the parabola through those points. For the g function here, this is in vertex form, so I'm going to get the vertex as my starting point on this. The x plus 1 inside gives me a -1 for the x value of the vertex. The -3 outside gives me a -3 for that vertex value. So -1, -3. Going to my graph and plotting that, we're going left 1, down 3. So there's my vertex. Now to get another point, I'm going to plug in an x value that's pretty close to -1, like 0. Let me just put 0 into the g function here. So that's 2 times 0 plus 1 squared minus 3. That's just basically 2 times 1 minus 3, which is just 2 minus 3, or -1. So 0, comma, -1 is another point. So that's over 0, down 1. There's my next point. And now if I just reflect that over the line of symmetry that goes through the vertex, I get my third point right here at -2, comma, -1. And that's enough to graph the parabola based off of those. For this problem, I notice that the function I'm trying to graph is in vertex form. So right away I can just get my vertex right out of this form. This x plus 2 in here gives me -2 for the x value of the vertex. The +1 outside gives me +1 for the y value. So we have a -2, comma, 1. Let me put that on a graph. -2, comma, 1 right there. And now to get another x value, or another point, I should say, let's just plug in an x value that's close to -2, like -1. Let me just do y of -1. So that's all this stuff with -1 plugged in for the x. -1 plus 2 is just 1. 1 squared is still just 1. So we have -1/4 times 1 plus 1. That's just -1/4 plus 1, which is 3/4. So plotting that out, we've got -1 and 3/4. So left 1 and up 3/4, which is about there. Now to get a third point, I can just reflect that weird point across the vertex to -3, comma, 3/4. And now that's enough to graph the parabola through the 3 points. For this next one, this is not vertex form, this is intercept form. So to graph this, I'm going to start by getting the x-intercepts out of here. So that's going to be whatever x values zero out each of the factors. In the first one, we have -2, and then -6 for that other x-intercept. So to get the vertex out of this, I just have to average these two together. -6 and -2 added together over 2. That gives me negative 8 over 2, which is negative 4. So that's the midpoint of those. To get the y value of the vertex, because I just found the x value, I just plug this back into the original function. So we have 3 times negative 2 times positive 2. That's 3 times negative 4, basically, which is negative 12. So that's a vertex of negative 4, negative 12. All right, let's graph all this. So I have an x-intercept at negative 6, another one at negative 2, and then halfway between those I've got my vertex at negative 4, comma, negative 12. And you'll notice on the y-axis, to make this fit, I made my y values go by 2s. So that's actually 6 grid lines down here. And then that's enough to graph my parabola. For this problem, I noticed that this is in intercept form, so I'm going to get the x-intercepts and use that to get the vertex. For the intercepts, it's just going to be whatever x values zero out each of the factors here. So to zero out negative x, I just have to plug 0 into that. To zero out x plus 6, I just have to plug negative 6 in there. So 0 and negative 6. Now if I average these together, basically add them and divide by 2, I get the x value of my vertex. So negative 6 over 2 gives me negative 3 for that x value, that axis of symmetry. To get the y value of the vertex, I just plug negative 3 into the g function up here. So that's negative 3, which is positive 3. This is another positive 3 over here. 3 times 3 is 9. So negative 3 comma 9 is my vertex. Let me graph all that now. We had an x-intercept at negative 6, another one at 0, which is the origin, and then halfway between at negative 3 comma 9, we have our vertex. Let me just graph my upside down parabola through all of those, and we're done. For this real life problem, we have a passenger on a stranded lifeboat shooting a distress flare into the air. So the height of the flare in feet above the water as a function of time in seconds is given by this f function right here, negative 16t and t minus 8. So that'll tell us everything we want to know about the first flare. The second flare, they just modeled with this graph here. So we have the same kind of information just represented in 2 different ways. Based off of this stuff, we want to know which flare goes higher and which stays in the air longer. And why do we want to know that? Well, I don't know. I mean, we're stranded on this lifeboat. Nothing better to do. Let's just figure it out. So we already know everything we need to know about the height and the time in the air of that second flare, right? It goes up to 196 feet, and it takes 7 seconds before it hits the water again, before it reaches a height of 0. But for the first flare, we're going to have to find the x-intercepts, or I guess they'd be t-intercepts in this case. And also we want to find the max for this function as well. Compare it to this other max. All right, so for our t-intercepts, since this is an intercept form, we can just zero out each of these factors. To zero out negative 16t, I just plug in 0 for t. And then 8 will zero out this other factor here. So 0 and 8 are my t-intercepts. Now to find the t value of my vertex, I just have to average these 2 things together. So 0 plus 8 over 2. That's going to give me 4. And if I want to know, so this is the time at which we reach our maximum value for that first flare. To find the maximum height, we just have to plug 4 back into the f function right here. So I have 4 times 8, or 4 minus 8 rather, is negative 4. 4 times negative 4 is negative 16, and negative 16 times negative 16 gives us 256. Now 256 is higher than the 196, so that means that the first flare, which is what gave us this function, is going to go higher up than the second flare. Which one's in the air for longer? Well, intuitively it seems like the higher one would stay in the air longer as well, but let's just double check. We have a t-intercept of 8 for that first flare. That means it takes 8 seconds for that first flare to hit the water. 8 is bigger than the 7 that we see in the graph here for the second flare. So the first flare is also in the air for longer.